Hi. So far in hypothesis testing, we've only looked at the cases when the alternative hypothesis has been either the probability or your proportion as being greater than something, or your proportion has been less than something. These are called one-tailed tests. And the reason they're called one-tailed test is you're looking in one direction. You're either looking at the direction that's greater than, so looking at one side, or you're looking at the direction that's less than. What we're going to do today is we're going to meet a situation where the alternative hypothesis is not equal to something. So instead of being written with an inequality, it will be written with an equal sign and a line going through it, meaning it's not equal to it. The wording of the question will not direct how it is changed. It will just say it is changed. So you've got to make a decision about which way to look. So there's a lot more going on with this type of question. So here's your process, and it starts off exactly the same as your one-tailed test. So the first thing you'll do is you set up your two hypotheses. Number two, you then, as always, assume the value of P from your null, and you get your value of N from your sample and your binomial. Now, that's all the same, absolutely all the same up till then. What you've now got to do is you've got to decide whether you find the probability of X is less than or equal to something, or the probability of X is greater than or equal to something. You know it's got to be one or the other. To do this, you look at the actual numbers in the question from your sample. So you look at what's been observed and you work out that proportion. Now, if that proportion or probability or percentage is less than what's in your null hypothesis, then you will find less than or equal, the probability of less than or equal to something. If it's greater than the value of P in your null hypothesis, you'll find the probability of X being greater than or equal to something. Here's the next twist. Because it's a two-tailed test from the not equal to in the alternative hypothesis, you'll compare this probability with half the significance level. So you're going to halve the significance level. So let's have a look at an example. So here we have, in the last general election, Party Z won 36% of the vote. So straight away, you've got your value of P, your probability or your proportion. An opinion poll surveys 100 people, there's your value of N, and finds that 45 support Party Z. Does this provide sufficient evidence at the 10% significance level that the proportion of voters who support Party Z has changed? So here's the difference, it's changed. Right, set up your hypotheses. Your null is 0.36, P is 0.36, but your alternative is that it is changed, so it's not equal to. Notice, again, I'm defining what P is. P is the proportion of people that vote for Party Z. Step 2, I assume the null hypothesis. X is binomially distributed where N is 100 and P is 0.36. This is what I mean when I say assume the null hypothesis. Just use that value of P. This is the status quo. Now let's find the probability of seeing this thing happen, this 45, in this world. However, what am I going to find? The probability of less than or equal to or greater than or equal to. So use these figures. 45 out of 100 is 0.45. Now that is greater than 0.36. So there's absolutely no point in testing less than. So all you're going to do, you use that and you find the probability of being greater than or equal to 45. You should be really good at putting that in your calculator now. I'm using BCD in my graphical calculator. Again, I'm using that with the new one. You would obviously have to work a bit harder if you're using an old one. You'd have to go back into run and do 1 minus less than or equal to 44. It's a bit more of a hassle. And your probability is 0.0397, so just under 4%. You're now going to compare this not with the 10% significance level, okay? because it's two-tailed, so there's the 10%, there's the two-tailed indicator, you will halve that 10%. So you will compare that with 5%. Now, 3 and a bit percent is less than 5%. So this is a very small probability. You are shocked. This is highly unlikely to have happened in this world that you've set up in your null hypothesis. Therefore, you reject the null hypothesis and then you put it back into context. There is sufficient evidence at the 10% level that the proportion of voters who support Party Z has changed. Okay, so that's one where we reject. I've done one where we're going to accept, and you can see I've slightly doctored this question. Certain school, the percentage of maths students who are girls, 34%. In a different school, in a sample of 90 maths students, 21 are girls. Is there evidence at the 1% significance level that the percentage of female students in the school is different, in the second school is different, right, from the first school? So they're not directing you, they're not saying, is it bigger, is it smaller? Just want to know if it's different. So that is a two-tailed test. So again, you set up your two hypotheses, proportion 0.34, alternative not equal to 0.34, and again, define your value of P. Assume the null, okay? Again, what that means is when you take your value of n, you assume this proportion, okay? Now, what are you going to do? Find the probability of greater than or equal to or less than or equal to. You're going to have to make a decision. So you decide that by looking at your actual figures. 21 out of 90. Now, as a proportion, that's 0.23, which is less than 0.34. So there's absolutely no point in testing greater than. You are going to test less than because that's where that figure lies. So you're now going to find the probability of X being less than or equal to 21. Again, that's in your calculator, your BCD. I've put the figures in there that you would put in: lower 0, upper 21, n is 90, probability 0.34. Now that works out as 0.0104, so just ever so slightly over 1%. You're now going to compare this with your 1% significant level, but it's two-tailed, so you have to halve 1%, which makes it a very tiny 0.05%. You can see that 0.0104 is greater than 0.005. Therefore, it's not, in this case, the probability isn't small enough to say it's a no-go, it's okay. Therefore, you don't reject the null hypothesis and then you put it back into context. There is insufficient evidence at the 1% level that the percentage of girls who do maths has changed. It's okay, you are not rejecting the null here, despite your figures being quite small. Right, exercise 18b. Question 8 and question 10 are worded two-tailed questions. You need to do those. You need to make sure you can do this. Then, if you look at question 2, that's got mixtures of one-tailed and two-tailed questions. It just doesn't have the words. So that gives you some really good practice on the actual skill.